Hello everyone, this is Ashutosh Sharma, and today I am making a video on the topic linear programming problems, which is a topic from operations research. So today I am going to discuss about linear programming problems with two variables, and we are taking an example to solve that problem. Here I have taken an example where you can see equations have been formed like this, where x1 x2 are the number of two types of products we have assumed. Like we have assumed that we will produce x1 units of product first and x2 units of product 2. Some information was given like per unit profit from first product is 40 rupees and per unit profit from second unit is 35 rupees. Some restrictions are also given, like we have given restriction of raw material. A special type of raw material is being used to manufacture the first product. So the total availability of raw material is 60 kg. That's why I have written this restriction here. What does it mean by this restriction? Let's see here, because we were given that 2 kg raw material is to be used to produce first type of product. So that's why the total raw material to be used to for making x1 units of product first would be 2 into x1. Similarly, if we talk about the total raw material to be used for making x2 units of second product, so we have given information that the second type of product uses 3 kg of raw material. That's why the total quantity of raw material would be used for making x2 units of second type of product would be 3x2. So this is the total raw material we can make use of, and this quantity cannot exceed 60. It may be equals to 60 or it should be less than 60. That's why this restriction is there. If we talk about the second restriction is machine hours. The total number of hours for which machines are available are 96 hours. The information was given that for producing one unit of first type of product is 4 hours. That's why the total time would be taken for producing x1 units of product first would be 4x1. Similarly, the information was given that one unit of second type of product requires 3 hours of machines. That's why to produce x2 units of second product would be equals to 3x2, the total time taken by the x2 units of second type of product. So this is the total time which would be required to produce x1 units of product A and x2 units of product say B. Okay, so two types of products would require this much of total time, and it cannot be more than 96. It can be equals to 96 or less than 96. Now the problem here is that the firm, those are manufacturing these two types of products, that how much units of first product and how much units of product second should be produced by the manufacturer, by the firm, so that these restrictions also can be satisfied and profit can be maximized. That's why I have written here this objective function is to be maximized. This is called objective function. These are the restrictions. Now there is a condition which has to be followed, that is called the non-negativity restriction. And what is that? Here at last we must mention that such that x1 and x2, those are the number of units of product first and second, cannot be negative. That's why we have to write it greater than equals to 0. So this is called the non-negativity restriction. So This is called the linear programming problem, because some information was given. On the basis of that information, we have programmed this mathematical model. So that's why it is called linear programming problem. Linear means all the equations in this model are linear in nature. Okay, so I hope that you have got the problem, what this problem is all about. Now, question arises that how do we can solve it? So in linear programming problems, there are two methods. Number one is graphical method and number two is simplex method. If number of variables are only two, so we can make use of graphic method. But if number of variables are more than two, in that situation we make use of simplex method. Today we are going to discuss just graphic method, because we have only two variables involved in this linear programming problem. So without wasting of time, let's start the solution. So before drawing the graph of for these equations, what we need to do, we need to make equations of the given restrictions like that. 2x1 plus 3x2 equals to 60, and try to find out the coordinates to draw the lines on the graph. So what we will do, first we will put the value of x0, x1 0. So how much value of x2 we would get? We will divide 60 by 3, so x2 would come out as 20. Then similar way we will put the value of x2 as 0 and find out the value of x1. So if x2 is 0, x1 would come out as 30. So these are the coordinates to draw the line for first constraint. Okay, so we can name it as first equation or first constraint. Second constraint is 4x1 plus 3x2 is less than equals to 96. 96. Okay, so this is your second restriction or second constraint. Here we need to keep it as equal equation so that we can find out the coordinates. So here coordinates would be, first put the value of x1 as 0 and find out the value of x2. So how much x2 would come out as? It would be 32. Again, put the value of x2 as 0 and find out the value of x1. So you can see that it would come out as 24 when you are keeping value of x2 as 0. Okay, so we have found out the coordinates. Now we need to draw the lines for these two equations on the graph. So we draw the graph in the first quadrant. You know that there are four quadrants, so in the first quadrant we will draw the lines for these two equations. And we can name it as graphic method or graphical method. Now we will consider or assume this axis as x1 and this axis as x2. We can name them as like this. Now the problem is for assuming the scale on these two axes. How do we should assume the scales on these two axes? For that, these coordinates will help us. What values we need to find out on these axes? Like we need to find out 20, 30, 32, 24. So I think it would be better if we can assume the scale at the difference of 4 4, because all the values are like 20, 30, 32, 24, all are divisible by 4. So it would be better to assume the scale at the difference of 4 4. So we can assume it is 4, like this is let it be little bit closer. So let us suppose this is 4, this is 8, this is 12, this is 16, this is 20, this is 24, this is 28, this is 32. Okay, Similarly, on this axis also we will assume, and like this, 4, 8, 12, 16, 20, 24, 28, and 32. This is your x1. After assuming the scale, we need to draw the lines for these two equations. Let's talk about the first equation's coordinates. 0, 20. We need to find out a point in this first quadrant where x1 is 0 and x2 is 20. So let's see where we can have x1 as 0. Always on x2 axis x1 would remain 0. So where you will have x2's value as 20, this point's coordinate would be automatically 0 and 20. So we can mention that this point would have coordinates 0 and 20. Okay, find out the point whose coordinates can be 30 and 0. So on x1 axis, x2 always would be 0. So here between 28 and 32, you may have the point whose coordinates would be 30 and 0. Okay, fine. So what we need to do, we just need to join these 2 points with the help of a scale. You can join like this and name this line as 1 because this is the line we have drawn by using the coordinates of first equation. That's why we will name it as 1, first line. Now we need to indicate the area above or below this line or on this line. Based on that, what kind of inequality we are having here? Because we have less than inequality, means we need to find out area in this first quadrant where x1 x2 can be so that when we put those values in this equation, this expression, that always come out as less than or equals to 60. So based on this inequality, we should indicate area below this line, which is indicating that on this line or below this line we are going to have values of x1 x2. Those would satisfy this restriction. Remember that our main focus is on finding values of x1 x2. Those would satisfy these both the equations simultaneously and maximize our profit function. Okay, so that's why we are doing all these exercises. Now again, find out the second line. Here coordinates were 0, 32. So in the same way, 0, 32 would be this point whose coordinates would be 0 and 32, and the second point would have the coordinates 24 and 0. 24 and 0 would have this point and coordinates. Now join these 2 points again and find out the line for the second equation. Okay, so we can name it as second line because this has been drawn from the by using the coordinates of second equation. Okay, now again we need to indicate the area. So again it would depend on this inequality sign. So this is because less than inequality. So again we will indicate the area below this line, which is indicating that below this line we will have the area where x1 and x2 would have values. Those would satisfy this second constraint. Okay, now because we need to find values of x1 x2 so that both the equations are satisfied simultaneously, so that's why now in this quadrant, after indicating the area, we need to find the common area, that is called feasible region. Okay, so if we talk about areas, so we can have different segments here. This is an area where we can have values of x1 x2, but here in this area values of x1 x2 would not satisfy the line, this line. Okay, this is the line drawn from the coordinates of equation 1. So this area cannot be the common area or feasible region. This area also cannot be the feasible region because this area is below this line but above this line. So we can easily find out that this area, okay, this area, I am indicating this area by shading it. So this is the area which I can say would have values of x1 and x2, those would always satisfy both the equations simultaneously, both the lines. So this area is having corner points. One corner point is this, second corner point is this, and the third corner point is this. One more corner point, that is the origin where x1 and x2 both are 0. So when we are trying to find out values of x1 and x2 with the help of corner points of visible region, we would not consider this because here we have x1, x2 both 0. So now a question comes, okay, we have found the feasible region. This is called the feasible region. Okay, this is called feasible region. Now, rule says that in this feasible region, try to identify the corner points of this feasible region, and rule says that at any one of the corner point, solution would exist. Solution would exist at any corner point. So how do we can check that at which point we will have x1 and x2? Those would maximize our profit function and simultaneously satisfy both the given restrictions. So it's very easy to check. Let's see. Find out the coordinates of point A. You know very well its coordinates are 0 and 20. Find out the coordinates of point C. Already I have mentioned 24 and 0. What about B? So to find the coordinates of B, because this is the intersection of equation 1's line and equation 2's line. So simply solve the equations which we have written here by using elimination method, and whatever values you will get of x1 and x2, that would be the coordinates of point B. So it's very easy. So simply solve these two equations. Somewhere in rough work you can solve it. I am solving here. So what I can do, I can write 2x1 plus 3x2 equals to 60, and 4x1 plus 3x2 equals to 96. If we subtract second from first, 3x2 would be automatically cancelled out. It would come out as 2x1 equals to, here we will get 36 minus k 36, and minus minus would be cancelled out. X1 would come out as 18. So after finding the value of x1 as 18, put the value of x1 in any of the equations. Suppose I am using the first equation. So let's see how much I'm going to get the value of x2. So simply you will get 3x2 equals to 60 minus 18 into 2, 36. So you will get x2 equals to, it will be come out as 24 divided by 3. 24 divided by 3, 8. So it means x2 would be your 8. So the coordinates of B point would be 18 and 8. It's so easy. Now what to do? Now it's simply put these values of coordinates, means values of x1 and x2, one by one in this objective function, and check that where you are going to have the maximum value of your objective function. So let's do that also. I am writing here. So let me make a box here where I am going to find the, I am going to check the value of objective function, because objective function is this. So when I am finding the objective function value at point A, I am writing ZA. So ZA would be 40. X1's value here is 0 plus 20 into value of x2 I have given as 20, 35. So it would come out as 35 to the 70 means 700. Okay. Now ZB, let's find out the value of Z, yani ki objective function at point B. That would be 40 into 18 plus 35 into 8. Okay, so it is coming out as 1000. So at point C, when we will calculate value of objective function, it would come out as 40 multiplied with 30 plus 35 multiplied with 0, and it would come out as 1200. 1200. Okay, so you easily can identify that where you are having the maximum value of your objective function. That is the point C. It means manufacturer should manufacture or produce 30 units of first product only, and he should stop the manufacturing of second product, because if he will produce second product also, then he is going to have less profit. So in this way we have learned that how to make use of graphical method to solve linear programming problem having two variables. So I think it will help you a lot to understand that how to we can make use of linear programming problems for maximizing our profits. So in my next video I will try to make a video. I will try to tell you that how to we can minimize the cost function by making use of the graphic method. Okay, thank you so much. Hello, goodbye.